Hey, welcome. Have you ever stopped to think that there's this secret world, a hidden reality playing out all around you? Well, there is, and it's all about chemistry. Today, we're going to pull back the curtain on the invisible battles and amazing team-ups that are happening constantly, all around us, and even inside our own bodies. So, let's start with a little riddle. What could heartburn, a painful bee sting, and, baking a delicious cake possibly have in common? I know, they seem totally random, right? One's a feeling, one's an injury, and one's, well, dessert. But I promise you, there's a single fundamental chemical principle that connects them all. And the answer to that puzzle is all about the epic story of acids and bases. Think of them as the main characters in our chemical drama. They're complete opposites, but when they finally meet, something brand new and amazing happens. So, all right, let's meet the main players. Okay, let's look at what makes them tick. On one side, we have acids. You know this taste. It's sour, like a lemon. Chemically speaking, their calling card is turning blue litmus paper red. And their secret move? They release hydrogen ions, that's H+, when they're in water. Then you've got their rival, the bases. They're bitter and feel kind of slippery or soapy. They do the exact opposite with litmus paper, turning it from red to blue. And their superpower is releasing hydroxide ions, OH-, in water. Total opposites. And believe me, you are running into these characters all day long. The vinegar in your salad dressing, that's acetic acid. The fizz in your soda, carbonic acid. That heartburn we talked about, yep, that's your stomach's super strong hydrochloric acid. And on the other team, you've got the soap you use, the antacids that calm your stomach, and even the stuff in some hair dyes. They're literally everywhere. So if we can't taste or touch every chemical out there, and seriously, please do not do that, how in the world do we tell if something's an acid or a base? Well, we bring in the chemical detectives. We call them indicators, and they are these amazing substances that change color to reveal a chemical's true identity. Trying to remember all those color changes can feel like a pop quiz you didn't study for. But don't worry, I've got a killer memory trick for you. Just remember this silly phrase, Lieber try popcorn with Mayer. Let's break it down. Li-B-R. That's litmus turns blue in base, red in acid. T-R-Y. Turmeric is red in base, yellow in acid. P-P-C. Phenolphthalein is pink in base, colorless in acid. And finally, M-Y-R. Methyl orange is yellow in base, red in acid. See? Now you've got it locked in. Okay, that's a great trick, but it raises a good question. What about folks who are visually impaired? Or what if you're in a situation where the color change is just really hard to see? Well, you guessed it, chemistry has a super clever answer for that, too. For that, we turn to olfactory indicators. These work with your sense of smell. And yep, there's another fun little story to remember this one. Just picture a giant factory. You go inside, get some vanilla ice cream, but then you decide to get a little weird with it and throw in some onion and cloves. Now, if you dip that concoction in an acid, you can still smell everything. But if you put it in a base, poof! The smell just vanishes. All right, so just knowing if something's an acid or a base, that's not the whole story. I mean, the acid in your stomach is way, way stronger than the acid in your soda. There are levels to this. So to really understand them, we need a way to measure their strength. We need a scale. And that scale is the famous pH scale. Fun fact, the P in pH comes from the German word Potenz, which means power. So it's literally the power of hydrogen. It's the simple scale, from 0 to 14, that tells us exactly how crowded a solution is with those H+ ions, which in turn tells us just how acidic or basic it is. You can think of this scale like a seesaw. It's a constant balancing act. On one end, if you have a ton of H+ ions, the solution is super acidic. On the other end, if you have a lot of OH- ions, it's super basic or alkaline. The key thing to remember is, as one goes up, the other has to go down. So here's the easy part. Anything with a pH less than 7 is an acid. Simple as that. And the lower the number gets, the more powerful that acid is. And right in the middle, at exactly 7, that's perfect neutrality. It's the balance point where the H+ and OH- ions are in harmony. The best example? Pure water. So, it follows that anything with a pH greater than 7 is basic, also known as alkaline. And the higher the number goes, all the way up to 14, the stronger the base. Let's put some real-world numbers on this. The gastric juice in your stomach is intensely acidic, down around a pH of 1.2. Lemon juice, also acidic, is a bit milder at 2.2. And then way over on the other side, milk of magnesia, which is an antacid, is a pretty strong base at a pH of 10. You can really see the massive difference in their chemical punch.
So, what finally happens when these opposites meet? It's the main event. It's called neutralization. This is the ultimate showdown, where the H+ ions from the acid and the OH- ions from the base finally get together, and they completely cancel each other out. And what's left after the battle? Two totally neutral things, plain old water and a new compound called a salt.
And there it is. We're back to our first question. When you have heartburn, it's because there's too much acid in your stomach. That antacid you take, it's a base. The moment you take it, you're kicking off a neutralization reaction right inside your own body to get that sweet, sweet relief. So what about these salts that are created? This chemical showdown doesn't just make things vanish, it actually builds some incredibly useful stuff. And I'm not just talking about the salt you put on your French fries. These salts are world shapers. Let's talk about baking soda. It's a mild, basic salt. Now, a bee sting is painful because the bee injects acid into your skin. So you put a little baking soda paste on it, and boom, neutralization. The pain goes away. And when you bake a cake, the baking soda reacts with other acidic ingredients, releases gas, and makes the cake all light and fluffy. And just like that, the other two pieces of our puzzle are solved. Then you've got washing soda. It's a different kind of salt, and it's an absolute powerhouse in all sorts of industries. It's used to make glass, soap, paper, and it has this incredible ability to soften hard water, which helps your laundry detergent work way better. Now here's a salt you probably never even thought of, plaster of Paris. It's made by heating up a mineral called gypsum, and this is the exact stuff doctors use to make a cast for a broken bone. It starts as a powder, but when they add water, it triggers a reaction that turns it back into a hard, solid cast, holding your bone perfectly still so it can heal. Pretty amazing, right?
So when you get right down to it, this whole balance between acids and bases is absolutely crucial. I mean, our blood has to stay in this super narrow, slightly basic pH range, or we literally couldn't survive. When rain gets too acidic, it can damage entire ecosystems. And yeah, even your teeth are in a constant pH battle every day. That's why toothpaste is basic, to fight back and neutralize the acids that cause cavities.
It really is incredible, isn't it? This constant tug-of-war between acids and bases really does govern everything, from how we bake a cake to how our bodies stay alive. And that leaves us with one last big thought. If this delicate balance is the secret to life on a tiny, microscopic scale, what are the consequences when we start disrupting that same balance on a planetary scale? That's something to think about. Thanks so much for joining me.